Our next speaker has spent his career shaping the very foundation of aging science. As scientific director of AFAR, Dr. Stephen Austad has helped guide some of the most influential geroscience funding in the world. He is also a renowned evolutionary biologist and author, asking bold questions about why and how we age. Let's welcome Dr. Austad to the stage.
Thank you, Dylan, and thank you, Eric, for introducing my topic. I thought I might have to spend the first time explaining what geroscience is, but what I'd really like to do, continuing to set the context for the rest of the meeting, is to explain why I think pursuing geroscience is an imperative. It's not an option. It's not something that we maybe should do. It's something that we can't avoid doing. So I'd like to explain why. Now, the key thing about geroscience was implicit in Eric's argument is by actually targeting aging processes itself, the possibility is, to the extent that we're successful, we can push back multiple diseases and debilities associated with early life at the same time. So, question, what is the number one threat to human health today? Sorry if there are cardiologists in the audience, but it's not heart disease. It's not cancer. These are the two things that kill more than half of us at this point. It's not Alzheimer's disease. It's not even obesity. None of these things are as big a threat to human health as aging. And I'd like to take just a couple of minutes and defend why I say that. Here are some risk factors for dying of heart disease. And you can see the common ones, the things we've spent the last 50 years trying to get people to cut down on their hypertension, smoking, cholesterol, diabetes. What I'd like to do is put those risk factors in context by comparing them to the impact of aging. And if I do that, that's what happens to them. They pretty much disappear into the x-axis. And I could do this with disease after disease after disease. Similar thing for cancer. These are 4 risk factors. If I put aging into that context, this is what happens. It dwarfs everything else. And finally, I can't avoid talking about Alzheimer's disease, since we're making such a big effort to do something about Alzheimer's disease at this point. Don't worry, having sex is not a risk factor for Alzheimer's disease. This is to point out the fact that it's the only one of the top 15 causes of death that is more that women suffer from more than men. But diabetes, physical activity, the ApoE, if you have the wrong allele, it increases your chances of contracting Alzheimer's disease by 5 to 10-fold. They pretty much all disappear when we add aging into the context here. So let me just step back now and talk about, well, how are we doing with traditional medicine? What are the challenges of traditional medicine, and what can geroscience do that traditional medicine can't? Well, for one thing, everybody knows the globe is aging. U.S. is aging. In the U.S., between 2000 and today, there's been a nearly doubling of people 65 and over. By 2050, there's supposed to be another increase in 50% beyond this. These are the things, I'm going to focus on the year 2000 and say we're a quarter of the way through the 21st century now. Wow, that was quick. But how are we doing now compared to how we were doing in the year 2000? In the year 2000, this is 8 of the top 10 causes of death. And the percentage of deaths that were caused by them, you can see that cancer and heart disease were 53%. If we add in stroke, that's 60% of all deaths. So since the year 2000, there's been a concerted effort to address all these with traditional medicine. And I have to say, those efforts have been incredibly successful. This shows the reduction in the age-adjusted death rate from all of these diseases. You can see all 8 decreased dramatically. Heart disease and stroke by almost 40%, influenza by almost 50% deaths from that. So what has been the consequence of all this progress on disease-specific research? That's the consequence. In the last 25 years, only goes up to 2019 because I didn't want to include the COVID years in there because we haven't yet emerged from the COVID years. That would have artificially made life expectancy look considerably worse. But you can see there's been a minimal impact in the last 25 years on life expectancy. If instead of looking at total life expectancy, we look at healthy life expectancy, there's actually been a slight decrease in healthy life expectancy since the year 2000. So despite our success at dealing with disease after disease after disease, we haven't done anything for really increasing healthy life. And that's what geroscience is all about. And if we don't do anything about it, as the 21st century progresses, what we're looking at is more dementia, depression, frailty, osteoporosis, all of the maladies of later life, both the fatal maladies and the maladies that just degrade the quality of life, like chronic pain, incontinence, blindness. And of course, ultimately underlying all this is going to have to be a massive increase in healthcare costs. So that's the situation that we find ourselves in here in 2025. And the question that I'd like to raise that really points out the geroscience imperative is, what if there were a pill? And like Eric said, a pill is only one of the many things that we're looking at now, from lifestyle to reprogramming of cells, to lots of stuff. But let's just imagine for a second that there was a pill that if we took it every day, it would actually slow the rate of aging by some effect. Well, it turns out there actually is a pill. And I've got that here to remind me that what I'm going to say from now on only pertains to mice. But the thing is, we want to know how much that might pertain to people. So here's a pill, rapamycin. Its effect on longevity was discovered in 2009. There's been multiple studies on mice that show that it extends life. There have been multiple studies that show that it prevents completely or delays a number of cancer types, delays the development of heart diseases and atherosclerosis or heart dysfunction, rejuvenates stem cells, enhances and even broadens vaccine protection. I'd like to focus on that because that's one of the few effects that's also been replicated in humans. So the mouse work, I thought, would never translate to humans because the mouse immune system is a funny kind of thing. But in fact, it did some very nice studies by Joan Manick. Delays and slows Alzheimer's, mouse versions of Alzheimer's disease, even of all things, retards the progression and delays periodontal disease. Pat Kaberlein's lab actually discovered that. Now, if you look at all of the things that this single pill does, we're looking at what geroscience could potentially contribute. And I'd like to point out that for mouse work, the gold standard for determining whether drugs affect longevity or aging is the NIA Interventions Testing Program. It's the gold standard because all three of these groups are very, very expert at doing mouse studies. And the same experiments, the same drug tests are done in these three places simultaneously. So when they come out with a positive result, it's something that you can really take to the bank if you're a mouse. Now, rapamycin is not the only drug. I've got up here a list of 8 other drugs that have extended mouse longevity by at least 10%. But just imagine if we could extend healthy human longevity by even 10%. Doesn't sound like much, but that's another almost a decade of healthy life. Really interesting things have emerged from this, something that traditional medicine has not known about at all, which is many of these things are sex-specific. You can see that 8 of the 9 only work in males. When I say only work in males, that is only extend life by 10% or more in males. Some of them actually extend the life of females, but not by that much. Now, this is something that those of us in the field were totally shocked by. Nobody anticipated this because mice, generally speaking, do not have the same sex bias in survival that humans have. Male mice are just as likely to live longer than female mice, depending on studies. So that's a shock. And this actually gives us a whole new area of research to pursue. Why is it? What can we learn from these drugs about why they only work in males? And do we need a different set of drugs for females? And the most important thing is, do these mouse experiments actually translate? Are they telling us anything about the human condition? The only way to do that is actually move some of these into human clinical trials, which is something that I know the advocates, and so do we at AFAR. The other thing that was shocking was that these drugs often work when they're initiated relatively late in life. That top one there, the hydroxyestradiol, 12 months is roughly equal to 45 years in human equivalents. And you can see the rapamycin has had a major effect even as late as the human equivalent of 70 to 75 years, and all of these other things. So we've discovered that there are multiple drugs that can make mice live longer. We don't know if the same drugs will work in people, but it's time to find out. We also know that there's a sex specificity that we discovered in mice. That's something we also would like to find out if that's true in people, and there's no way to do that unless we do the trials. And then we've discovered, and for those of you who know about my billion-dollar bet with Joe Sansky, this is something that's near and dear to my heart. We've discovered that you can start these things relatively late and still get a major benefit out of them. So what do we need to do to accelerate progress? Well, this is a whole conversation that we'll probably be having for 2 days here. Just the two things that I think are quite clear is we need a clear path to FDA approval for these drugs to the extent that they're successful in humans or other interventions. And then you also need the resources. You know, mouse experiments, those of us who study mice like to talk about how expensive lifespan studies are in mice. Well, mouse studies are trivially expensive compared to human studies. We need the resources. I'm delighted that you guys got your $52 million. That's the kind of thing that we need to replicate across the country. So I'll stop there. I hope I've provided a context and given you some idea about why pursuing geroscience is really an imperative, not an option. Thank you.
Can I ask you to talk a little bit about the advantages of the clear regulatory pathway for aging? So if you take an example like the GLP-1 RAs, which I think, and some people are beginning to think are maybe the first longevity drugs, what would having a clear regulatory pathway that targets aging as opposed to a disease like diabetes do for us in the field?
Yeah, well, that's a really interesting question. Why do we need some sort of special FDA approval process? I think so that people could be thinking about drugs as gerotherapeutics rather than disease-specific drugs. I think the GLP-1 story is really interesting. Oh yeah, we pursued this because of diabetes. And by the way, I think all of us in this room who work in geroscience ought to be embarrassed that we're not the ones to come up with the GLP-1 agonists. And then it went from that to obesity. And we could do that. I mean, I went to the FDA almost 10 years ago now to talk about metformin, and that's exactly the approach we used. Well, let's try about metformin for cancer, metformin for heart disease. So there are alternative ways, there are alternative routes, but I think if we really want to get investment in the field, the best way to do it is actually get an indication for something that looks like aging itself.
I have a question. In the market, there are also these rapalogs, or there's been a lot of research going on rapalogs. How do you think the efficacy of rapamycin compares with rapalogs, or why having rapalogs is better?
Well, rapalogs are an attempt to get around some of the side effects and increase the bioavailability of things. I could have done this. Actually, I kind of mixed and mashed together in my talk there. Some of the studies that I did were actually done with rapalogs rather than rapamycin. I think that we can always improve these natural products. If you think about it, all of our pharmacopoeia originated with natural products, which we then improved upon. In fact, even the GLP-1s, I love to talk about the fact that those were inspired by toxins in the saliva of Gila monsters. So we've taken basically a natural product and improved it chemically, and I think we've gotten very good at that. And the rapalogs, there's a ton of research going on. There's less side effects, more efficacy. I think it's a really important area of research.